So here we've got a question from Shibu Mohlalo. And let's see what this question is about. We are also talking about electric circuits. You can see we also have something in parallel and all that stuff. Okay, let's take this one step at a time. So we have the two graphs below show the relationship between current and potential difference for two different conductors, which is X and which is Y. Just to already say, if you already see a graph of something and something like that, you must always think Ohm's law. Remember, he talks about conductors, constant temperatures, things that are directly and inversely proportional to each other, and that is then how we can show it on a graph. And also remember, we know this for mathematics, the shape of the graph is very important. It can either be an increasing graph, a decreasing graph, it is a straight line graph, and so forth. So we are taking in a bit of mathematics and we're bringing it to physical sciences. So we have two conductors, which is X and Y. Remember, when we talk about conductors, we talk about materials that can readily actually conduct heat, electricity, and sound through them. So the graph is the current versus potential difference for two different conductors, which is X and Y. I can see that my current is going up, my potential difference is moving horizontally. I can already see that X and Y have got different graphs. 9.1 says we need to state Ohm's law in words. So I already did in the previous one. If you just joined us, when we state Ohm's law, it says the potential difference across a conductor is directly proportional to the current in the conductor at a constant temperature. I hope you're already seeing what is happening here. What happened in the previous question? They first asked us about Ohm's law and all that stuff, got us nicely warmed up before they actually started asking us about the electric circuits. So as you can see, there's a common trend with such questions. And most of the time, guys, you'll see when you start practicing your question papers, you'll see that some of the questions actually come repetitively. And some of the questions are the same structure as you move along. It's first a definition, calculate the reading on A, calculate the total current. You see, it's a constant thing as we move along. Okay, without wasting time, let's move. So we've already done Ohm's law, that is 2 marks in the bag. Then it says, which one, don't say X and Y, my darlings, which one of the two conductors, X or Y, is ohmic? We must refer to the graph and give a reason for your answer. Now, something we need to know when we talk about Ohm's law, it's directly proportional. If something is directly proportional, it means if the one increases, the other one also increases. The harder you work, the greater your results, and stuff like that. So it is directly proportional. If something is directly proportional, it means that we have to have a straight line graph. There shouldn't be a curve somewhere like these velocity time graphs or graphs that we actually use. It should be then a straight line. So let's see between X and Y, which one will then be a straight line going up. I can see that X is actually a straight line going up. So I can therefore say, let me work here. So let me just do this. 9.1 we did was Ohm's law. I've got 9.1.2. Which one between the two? It is X. We must give a reason. Remember, so you can say it as graph X is a straight line. Graph X is a straight line, and therefore potential difference is directly proportional to current. It's directly proportional to current. So that is the reason we can give. Let's see for how many marks for this. It was for 2 marks. You get a mark for stating which one is X or Y and giving a reason. Now remember, they said you must refer to the graph and give a reason. They didn't say just give a reason. If they just said maybe give a reason, you could have used Ohm's law to actually support your answer to why you chose X, right? In terms of the rules and laws we know in terms of conductors and non-conductors of electricity. In this case, they said refer to the graph. The graph showed us 2 conductors, one which had a straight line and one which had a curve. Now we know from Ohm's law, it has to be directly proportional. Directly proportional means if the one increases, which means we should then have a straight line. You must be careful on how you reason, because the examiner carefully tells us here, refer to the graph. So we've referred to our graph and we already made our decision. So 9.2 says, in the diagram below, a battery with EMF of 6 and an internal resistance of 2 is connected to 3 resistors, P, Q, and R. The voltmeter V is connected across the battery, which is this one over here. The ammeter A has negligible resistance. Now 9.2.1 says calculate the ammeter reading when switch S is closed. So here is our switch S. If we close switch S, what will be the reading on the ammeter? This was fairly an easy question. How will I tackle it? Now remember, you've got resistors in parallel. This can technically, we can calculate this so that it's one resistor, making it in series with the 10 ohm resistor and the 2 ohm resistor. I've got my I then can find my A. But I know I have 2 ways in which we can do it. So let's tackle it. So the first way we can do it, I'm going to find my total resistance. Remember to always show the examiner what you're doing. I'm going to start with P and R. They are both resistors in parallel. That's how we show it. I'm going to say 1 over R10, the 10 ohm resistor, 1 over R, the other one is 15. I'm going to say 1 over the 10 ohm resistor plus 1 over 15 ohm resistor. Put it in our calculator exactly as it is. I'm going to have 1 over 10. Let's go back. Plus 1 over 15. I therefore get 1 over 6. I'm going to get 1 over 6. I do the reciprocal or the tip and tap. I say 6 over 1, which then means the resistance here is then 6. Remember, the SI unit for resistor is this funny looking maniki here, which we call ohms. So this is then 6 ohms. Now 6 ohms is in series with 10 and again with 2. So therefore I can say my R total for this circuit, it is a 6 ohm that I got from the parallel resistor plus the 10 ohms plus the 2 ohms, which then gives me a total of 18 ohms in the circuit, right? But now they said we must calculate the reading on the ammeter, so we are not yet done. So therefore I have 2 ways on finding the current. I'm going to make this number 1. I can therefore say R is equal to V over I. We know this from Ohm's law, but I'm looking for I. Making I the subject of the formula, I'm going to have I is equal to V over R. My potential difference, they gave it to me. It is the 6. And I just calculated my resistance, which is 18. And let's see what we have here. If I say 6 over 18, this gives me 0.33, and that is my current. 0.33. The SI unit for current is a capital A. Another way you could have done it is you could have used the long way around, where we have this formula, which is I, external resistance, internal resistance. My current in the circuit is what I'm looking for, but they've given me E as 6. I'm looking for I. The resistance that I have, I've got the 6 here, I've got the 10. Remember, that is internal resistance. So I can therefore say 10 plus 6 for my external resistance plus 2 for my internal resistance. Just do it over. So here we're going to have 10 plus 6 plus 2 will give me 18. That I can do in my head. To find I alone, I divide both sides by 18. 18 divided by 18 is 1. I'm left with I. This looks exactly the same as that. So don't say I'm a genius, but 6 over 18 gives me 0.33. The SI unit for current is then a capital A. So as you can see, you could have used this method or this method, and this was then going for 4 marks. The only tricky thing, you needed to look that these two were in parallel, but in series with all the others, and to take note that the 2 ohm resistor was then internal resistance, right? And that is then how we would have tackled this question. Remember guys, with electricity problems, they remain the same. Practice, practice, and practice.